वेलकम टू एस इंजीनियरिंग एकेडमी ऑनलाइन प्लेटफॉर्म। एस इंजीनियरिंग एकेडमी ऑनलाइन प्लेटफॉर्म में आपका स्वागत है एंड टुडे वी आर गोइंग टू डिस्कस गेट 2023 कंप्यूटर साइंस पेपर। We are the team of computer science and one after another subject which where we are going to discuss the memory based questions. Over to you, Ramesh sir.
Yeah, we are going to discuss about each subject and in each subject what are the questions are covered and from what topics are it is covered and what is the analysis of each question, and that we are going to discuss, and overall we will discuss about whether the paper is moderate or easy or tough, and we'll go with one by one, and you are going to get solutions for all of the questions. Okay, we'll start the session. Hello students, myself your Ramesh Masuna sir. I'm going to analyze the total GATE 2023 computer science paper, from which subject questions are asked, from which how many number of questions are asked, and what is the total marks from each subject, and what is the analysis of that GATE 2023 CSE paper. Very first, we'll see how many questions and what are the marks in each subject. From databases, this time the total number of questions are 3 and marks is 5. It is less when compared with GATE 2022 paper. In GATE 2022, we got 5 questions of 8 marks. Here this time it is only 3 questions are of 5 marks. And next, when it comes to the TOC and compilers, in TOC and compilers, totally 5 plus 3. Here this time it is a good number, and 5 plus 3. Here actually CD, there is one more question, we got it, and there are totally 6, this is 6 marks in the compilers. In TOC and compilers together there are 9 questions, and 8 plus 6, 14 marks asked this time. When compared with the 2022 paper, it is better marks from TOC and compilers. And in programming it in data structures, there are 8 questions of 11 marks, and algorithms there are 3 questions of 5 marks. And when it comes to this set of subjects, digital, COA and operating systems, these are the related subjects. When it looks digital, COA and OS, 4, 6, 6, totally 16 questions have come from this connectivity subjects. 16 questions is not less, it is very, very good number of questions. And totally how many marks you look? 6 plus 10 plus 9, 25 marks from digital, COA and OS. And people who have concentrated more on this digital, COA and OS are going to get very good marks. And you look this programming DS algorithm, this set, you got 11 questions and of 16 marks. And the TOC and compiler is one set, there are 9 questions, instead of 3 plus 1 we can say 4 questions. 9 questions and 8 plus 6, 14 marks. And DBMS this time is less, and look for the last computer networks in a core subjects. There are 5 questions and 8 marks. In the last year, it is nearly 12 marks from the computer networks. And look for the non-engineering sites, like we can call discrete mathematics, engineering mathematics, and aptitude. And discrete mathematics, totally 6 questions and 9 marks. In engineering mathematics, 5 questions of 6 marks. Look for this set, engineering mathematics side. There are totally 11 marks and 11 questions of 15 marks. As usual, aptitude will have 10 questions of 15 marks. In that, nearly 5 questions of English and 5 questions are of numerical ability. Totally 15 marks. And this is a paper analysis of GATE 2023. And when it comes to the paper, and we cannot say it is too easy, and we cannot say it is too tough, we can say it is a moderate. And it is from the feedback of many students, it is understood that paper is not too easy, not too tough, but paper is somewhat tricky. They have given some confusing statements. If a student had a good command over the subject, they can able to answer the questions easily. Those who prepared moderately, definitely those students are going to be in a traps. So they may think that their answers are correct, but there are the traps are there because they confused with the statements in the questions. Some little twists are added. Okay, that's what overallly I can say the paper is a moderate. But here you can see minimum 30% of the questions are very easy questions, means by looking the question you can able to answer. Nearly 40% of the questions are moderate but tricky, and remaining 40% of the questions are, those are difficult question we can say. And last year we got multi-subject questions. This year we didn't get any multi-subject questions, but there are 1 or 2 questions. But those questions can be claimed in programming and the CO and programming and OS like this. When in an operating system, one page faults question is given and there is an array question, array representation given row major order. So we can claim this as a programming question or operating system questions. Hardly you can see 1 or 2 multi-subject questions. But when it compared with the 2022 paper, they have twisted a lot with difficult questions in the multi-subject questions. That kind of twisting and complex questions are not there in this year. But overall, it is a very good paper, definitely. And coming to the multiple choice questions, that out of 65 questions, 34 questions are multiple choice questions, MCQs. And for the MCQs, obviously, you know that there is a negative marking is there, 1/3 for 1 mark, 2/3 for 2 marks questions. And numerical answer type questions are 60, fill in the blanks, you don't have any negative mark for this. And multiple selection questions are 15, means the no negative mark questions are 31 and MCQs are 34. Totally 65 questions. And again, as usually, the people think that numerical answer type questions, MSQ questions, most of the students think that those are easy and correct. But those are going to play a good role for your rank, for your marks in this 2023 year also. Why? Because you don't have partial marks for the MSQs. Okay, MSQs are now going to play an important role, and I hope you observed it. In 21, 22, 23, the number of MSQs and NET questions are increasing. You have to focus on it. Right. And moreover, after we collected questions from our students, memory-based questions, what we observed, means me and our co-faculty observed, is 90% of the paper is from ACE offline classes. Means the whatever the questions, whatever the concepts that we have discussed, almost more than 95% of the paper is similar questions. Let us an example. In ACE Engineering Academy booklet, we have one question on syntax directed translation where the binary to decimal conversion. Same question as it is, just only the variable names are changed. Same question appeared in the GATE 2023 paper. That's what I'm telling you. Most of the questions are from our classroom coaching, and also I can say our online coaching, and also pre-recorded videos, and also from our test series questions. most of the test series questions. Only the name changes, value changes are done. Like I can tell you one question. In DBMS, I have given a question in ACE test series for finding the number of block accesses using the primary index. Total question is same, just only the values are changed. That's what I'm telling you. 95% above questions are from ACE offline, online, and pre-recorded and test series questions. We can proudly say that. So paper come from our platforms. Okay, and when it comes to GATE 2023, as we have discussed that paper is moderate and a bit tricky, and easy questions are there, tough questions are there. When it comes to the cutoff marks, means a good student can able to manage to get minimum 60 to 65 marks, those who have a good command over the subject. But a student who moderately prepared and have a good depth over the subject, there are tricky questions there, it will be a trap to them, so they are not able to manage to get good marks. But ultimately, this time also cutoff marks should be as usual. You may expect for the general category 25 marks. So if you get 25 marks, mostly this is going to be the cutoff marks for the GATE 2023 paper analysis, right, for the general category. This is overall analysis of all these subjects, and now we are going to discuss the individual subject paper analysis, what are the questions we have collected from our students, memory-based questions, and those questions subject by subject we are going to discuss. Okay, and you can cross-check your solution with our explanation so that you will have an idea how many marks you are going to cover it. So let us start with the databases, because I'm a faculty in ACE Engineering Academy for the database management system and compilers. I'm going to cover both the questions, subject questions. And here in DBMS, there are totally 3 questions and consisting of 5 marks, 3 questions of 5 marks. And 1 question is from the relational model. It is a theoretical question, true or theoretical question. Some state degree question is given. Which of the following is a correct for the degree or RET of a relation model? There are certain statements are given. We need to find which is a correct question, correct statement. That all I'm going to discuss. And actually, the first time, it is a fun thing in SQL question. Most of the times, every time you are going to get very complex question consisting of various concepts like nested, correlated, set manipulation operators, many tables are given. The question is a bit complex every time, but this time it is very fun, very easy question, straightforward question is given. And that to 2 marks. Actually, if I have to talk about that SQL question, it is not worth for 1 mark, but it is given for 2 marks. We'll discuss that question also. And 1 question is indexing. Actually, the question is very straightforward question. They have given the length of the question is too much and given a lot of analysis of that question. By looking that question, most of the students will stop attempting it because the length of the question is more than 1 page. But the question is very simple. If you know the concept, you can easily answer it. Orally, DBMS questions are very, very easy. Okay. The 3 questions, I'm going to make an analysis of it. The first question, as I told you, 1 question is from the relational model. Which of the following is correct about degree, or we call RET in a relational model? The degree in a relational model says the number of attributes. Say we have a student relation. In a student relation, we do have certain attributes, rule number, name, and marks. Certain attributes are there. And these attributes, the number of attributes are called degree. And whatever the tuples that we have, 1A 25 and 2B 36, and the number of tuples is called cardinality. Now here in this example, cardinality is 2 and the degree says, here degree says 3, right? Degree says 3, cardinality is 2. Degree means the number of attributes in a relation schema. Look, what are the options are given? It is a number of entries. Number of entries is called cardinality, not the degree. So option A is wrong. Option B. It is a number of attributes in the relation schema. This is a perfect statement. Answer is option B. Option C says it is a number of records in the relation. Number of records are entries. So we can call one record is called one entry. This is the same statements and it is also representing cardinality but not the degree. And the option D says it is a number of distinct domains. This is incorrect. Distinct domains does not have any name and that is incorrect. The correct answer is it is a number of attributes in the relation schema. In the relation schema, whatever the number of attributes are there, that is called degree. And this is a SQL question asked for 2 marks actually. It is a 2 marks question. But look the funniest thing. What is a simple question it is given? First time I hope for 2 marks this much simple question is given. Consider the relation student where roll number is primary key. They have given a student table in which roll number is a primary key. Roll number, name, gender, marks. And there are 5 tuples are mentioned. 5 tuples are mentioned. The question is the number of tuples in the output of the following query. It is a numerical answer type question, NAT question. How many tuples in the output of the following query? Look at what is the query? Select star from student where gender equal to F and marks greater than 65. This is a simple question. We have to check the rows for these 2 conditions. Gender equal to F false, true, true, true. This is false. For these tables, marks should be greater than 65. This is 80 greater than 65, 90 greater than 65. And Shweta is a female and marks is 65 and condition 65 greater than 65 is false. So how many tuples are going to be selected? These 2 tuples are going to be selected. That is 2 Alia female 80 and 3 Alia female 90. So how many tuples it is going to be returned? The number of tuples returned is 2 tuples. And it is given for 2 marks. It's a very simple question. And coming to one more question, which were asked on the concept of indexing, and mostly the question is on primary indexing. Actually, there is a lot of theories given about this question. Length of the question is very big, but whatever the data we have collected, based on the data, I am going to give you the solution for it. Ultimately, in the question it is mentioned, there are totally 25,000 records in a database and these records are ordered. It is mentioned there are ordered file. This file is ordered file and each record is 100 bytes and in that key field is 15 bytes. And in this key field is 15 bytes and a big diagram is given how these records are added. And for each index record, there is a pointer to one block in the data file. It is also mentioned block anchors, means it is using the primary indexes. And in the primary index, it uses a key and pointer pairs, and the pointer is 5 bytes, it is mentioned. And the blocks are of size 1024 bytes, it is mentioned. The question, the motto of the question is, if primary index is created on the data file, then the number of blocks to access using primary indexes. How many blocks to access using the primary index? It is asked about worst cases. Worst case, how many blocks to be accessed on a using primary index. There are certain formulas also mentioned inside a question. You need not to use your brain, and most of the things are there in the question itself. And also mentioned, each record you can find in one block. It is no spanning of the records. It means the records are it is using unspanned strategy. What is unspanned strategy? So means every record you can see in one block, no record can be stored in more than one block. There is no spanning of the records, and if there is no spanning of the records, you have to use some certain considerations while you are calculating the blocking factor and number of blocks. So ultimately the question is on primary index and how many blocks to be accessed using primary index. What primary index requires? It requires to create one index record for each block in the data file. First of all, we need to find how many blocks in the data file. To calculate the number of blocks in the data file, first we need to find the blocking factor for the data file. What is a blocking factor? Block size by record size. What is the block size given? 1024, record size is 100 bytes. And it is 10 records per block. And what we have to take here? Lower bound. It is clearly mentioned no record is going to be stored between the two blocks, means every record is available in one block, means no spanned strategy, it is unspanned strategy. 1024 by 100 will be give you 10.24, means 10 records possible to store in one block, but where you can store that 0.24 you have to store in the next block. That's why you have to take the lower bound. Means in each block we store 10 records. We call 10 records per block. What is the number of data blocks? Number of data blocks. The number of data blocks, how do you calculate number of data blocks? Total number of records by blocking factor. How many records total? 25,000 records. What is the blocking factor? 10. Means how many blocks? 2,500 blocks. It means in primary index, for each block we have to give one index record. Means totally 2,500 blocks. It means 2,500 index records we have to create it. So what is the size of index record? What is the size of index record? Size of index record is key size is 15 and pointer size is 5. 15 plus 5, which is equals to 20 bytes. Because index is always consisting of key plus pointer. Key is 15 and pointer is 5. 15 plus 5, 20 bytes for the index record. And what is the blocking factor for the index file? The blocking factor for the index file is 1024 by 20. This is equals to 51. Point something, we have to take only lower bound. 51 point something, we have to take 51. So how many number of index blocks? Number of index blocks. How many index records we have to create? For each block, one record we have to create. Totally 2,500 in data blocks are there, so that 2,500 index records we have to create, and these index records to be stored into the block with a blocking factor of 51. So 2,500 by 51. So 2,500 by 51, you will get 49.01 something. 49.01 something means how much you have to take? Is it 49 or 49.01 or 50? Just think about it. So 2,500 by 51, it will give you 49.01, means 49 blocks anyhow it is required. Where do you store that 0.01? That 0.01 means some part of a record is left, means whichever the record is not able to fit in that 49th block should go into 50th block. Means here it is upper bound. And this point is also mentioned in the question. Okay, so totally 50 blocks. Now finally what is asked? Average number of block accesses. Average number of block accesses. The average number of block accesses are equals to log 50 base 2 plus 1. Log 50 2 power 532, 2 power 664 means log 50 base 2 is 5 point something. 5 point something is 6 plus 1. What is that 1? 1 block in the data file to be accessed. Totally how many blocks to be accessed on the data file? Sorry, using the index, 7 blocks to be accessed. Answer for this question is 7 block accesses. It is also for 2 marks, and there are 2 marks questions and 1 mark questions, and these kind of questions we have discussed in our live classes, offline classes and everywhere. Okay, I hope you might have done these 3 questions correctly, and coming to DBMS, I can definitely say it is very easy questions. These are very easy questions. Okay, next we'll go ahead with one more subject called compilers. Okay, from the compiler there are totally 4 questions. When it compares to the last time, it is some better number of questions. In compilers, number of questions are 4 and total marks is 6 questions. And these 4 questions are, one question is on theory based, and that is also on phases, and another question is on lexical analysis. They have given lexical analysis patterns and ask you to find which non-deterministic finite automata is going to identify a token called ID. Means we can also claim this question as a combination of TOC and compilers. Okay, but question is simple. You can consider that as a TOC question or compiler question. And one more question on syntax directed translation. As I said, the question directly is a copy from our CD book, CD comparison booklets. Means copy, instead of saying copy, just names are changed, but same question. And same question is appeared in the test series, same question is there in the booklet, but only the variable names are different. The concept is same, which is a conversion of binary to decimal values. And one more question is on live variable analysis. And previously on live variable analysis, in 2021, one theoretical question is given, and that is based on the formula. In 2022, no question on live variables. Again, in 2023, actually it is a good question when compared with the previous one. Some program snippet is given, control flow graph is given, and asked to find what are the live variables at the exit of each blocks. Okay, that is also one of the good question. Totally 4 questions on 4 topics. We'll continue with each of the question one by one. The first question, this is based on the phases. Which of the following is a correct statement? They have given statement 1, statement 2, statement 3. 3 statements are given. And each statement, you read it, and options are given only S1, S1 and S2, S2 and S3, S1, S2, S3, like this some options are given. But finally the answer should be based on which statement is going to be correct. Statement 1 given, front end consists of the phases that are independent of the target mission. What are the front end phases in the front end? Lexical analysis, syntax analysis, semantic analysis, intermediate code generation, mission independent code optimization. And this comes under the front end phases, and all these front end phases doesn't require any knowledge about the back end. It purely depending on the features of the programming language. So this statement is perfectly correct. Okay, the statement 1 is correct. And look at the statement 2, backend. The backend phases are code generation and mission dependent optimization techniques. And code generation and mission dependent optimization techniques requires to have the knowledge about the mission, like what are the instructions, instruction formats, instruction length, and all that information is required to be known for target code generation. Means it requires to have the knowledge about the target mission. Means this backend consisting of the phases that are dependent on the target mission. This is also correct statement. It is depending on the target mission. And what S3 says, backend consists of the phases, again it is given about the backend, consists of the phases that are dependent on the programming language. Think, is it depending on the programming language? Which phases are depending on the programming language features? The front end phases, not the back end phases. So S3 is a false statement. So options are given. In that option, it is mentioned S1, S2 correct, and S1, S3 correct, S1, S2, S3 correct, only S1 is correct. Some options are mentioned. So here in these 3 statements, what we conclude? Both S1 and S2 statements are correct statements. This is a question for 1 mark. And one more question is given on lexical analysis. It is given certain. It is given like this. There is a lexical. There are the certain patterns used by the lexical analyzer, and they have mentioned patterns. Patterns for letter. They have mentioned pattern for letter. That is capital A to capital Z, comma small a to small z mentioned, and also given a pattern for digit. Consisting of 0 to 9, and mentioned pattern for ID, identifier, that is letter followed by letter or digit whole star, letter or digit whole star. This is mentioned. This is mentioned, and asked that which of the non-deterministic null NFA, non-deterministic NDFA, non-deterministic null NFA. This is null non-deterministic NFA. It is given certain 4 diagrams. In that 4 diagrams, which non-deterministic null NFA is going to identify the token ID. I have seen some diagrams from the students. It is mentioned some diagram like this. This is the initial state, and it is an input on letter, and this is a state on epsilon. Here there is a repetition of letters, and there is on epsilon move, there is one more it is a repetition on digits. Just think about it. Is it a correct representation? Think, is it a correct representation? What happens if it is a letter, then move to this state. After that, if it is again one more letter, it will move to the final state. But if after these two letters, if we have a digit, it cannot come to digit side. Say means an example like sum 1, assuming int sum 1. Sum 1 is an identifier. So on letter S, it will move to this state. On null move, it will take this side. And on U, repeated. And M, repeated. Right? But 1, we don't have a state. Right? It is not the correct representation. There is one more diagram given. That is, it is a start state. On a letter, it is moving to the final state where it is mentioned letter or digit. Okay, up to this is okay, happy. But they have added one more transition, that is epsilon. So what happens? Okay, if it is a letter followed by letters or digits are accepting. But here it is also accepting a null string. Identifier should never be a null. Why? Because this pattern does not generate any null. So this is not the correct one. It is incorrect, it is incorrect. And one more option given is like C option, or one more option given is on letter it is moving to one state and it is mentioned it is a final state. On epsilon it is going to this state. Here we have a letter. On epsilon it is moving to another state. On epsilon it is moving to another state where here digit is there and here epsilon move is there and there is a transition and from epsilon. Here you look at letter followed by any number of letters or digits and only single letter accepted. And single letter followed by any number of letters are repeated, or single letter followed by digits repeated, and letters and digits combination is also repeated. Letters and digit combination is repeated. This is a perfect diagram, which is a null NFA for the identification of a token ID. If you have chosen this option, this is a perfect answer. Okay, right. And some option D, given some diagram, that is also incorrect. And because it is MCQ, one option is correct, and this is a correct option. And this is one more question, which is based on the live variables, And one more question is on syntax-directed translation. Look at the question on live variables. They have given a control flow graph. CFG is given. Control flow graph is given. And control flow graph is given such something like this: block 1 to block 2 a transition, block 2 to block 3 to 4, and block 2 to 4, and block 4 to block 2 repetition. And it is mentioned it is entry, and it is also mentioned it is exit. Entry, exit. The question is, what are the live variables at the exit of each block? At the exit of each block means at this point we have to check. The live variables that are live at the exit of block 1, block 2, block 3 and block 4. Certain options are given. So that options exactly we didn't receive it. But I will explain you what are the live variables at the exit of block 1. Say, just remember, just recollect the definition of live variable. When a variable is live at that point P, assuming it is a point P, at this point P, when a variable is live at point P if there is a path from the point P to the exit. If there is a path from P to the exit, there may be multiple paths. In some path, if the variable is used before it is redefined. If there is a use of the variable, then we can call the variable is live. If it is redefined before it use, then we can call dead variable. Simple. Now look at this point. What are the variables we have? I, J, A. I. At this point we have to see, is I is going to be used along some path from this point, exit of the block 1, means from point P to the exit. is I is used? Look, here is a path, I is used. And don't look for the redefinition. When it is redefined, after use. Because it is used before redefinition, we can call the value of I, whatever is holding in the block 1 is going to be used. So means at the exit of block 1, the variable I is live. Look for J. The variable J, here you look, it is used before it is redefined. So I can call J is alive. Look for A. A is done. A is live or dead. If you look for this path, the value of A is redefined. A value is redefined. Whenever the value of A is redefined, we may assume that it is killed variable. But understand the definition. A variable is live at some point P if there is some path from P to the exit. In that path, some path means at least one path, in that path the variable is used before its redefinition. But here in this path, A is redefined. But look, there is a control path. You look from B2 to B4. When it, suppose if control takes from B2 to B4, along this path, A is not used here in this block B2, but A is used. Because the variable A is used from point P to the exit, in some path A is used, we can call A is live. So what are the variables are live at the exit of block B1? I, J and A. Look for B2 block. What are the variables that are live at the exit of block B2? Look, is the variable I is live or dead? Here at the exit I am talking. From B2 to the exit only one path. In this path, is I value is used? No. I is redefined. I is redefined. So means it is dead. It is killed variable. J, along this B2 to B4, it is not used. It is called killed variable. And A, at this point, A, from this point P to the exit, the A is used. So means A is live at the exit of block B2. I hope you are understanding. Okay, just you only think from block B3, at the exit of block B3, which variables are live. At the exit of block B3, is I is live or dead? Simple. From B3 to exit, only one path is there. In this path, I is redefined, I is dead, and J is not used anywhere. So J is dead. The A value used is live. And at the exit of block B4, any variables required to be live? Look, I, is it required to be live? See, from B4, one path is there, feedback path. From B4, one feedback path is there. So at the exit of B4, because a loop is there, you look, in this path, this is one more path is there. From here, there is a feedback path, means a loop to exit again. In this path, the I is used, I is live. J is used, J is live. A, in this path, used, A is also live. These are the live variables for B1, B2, B3, at the exit of B1, B2, B3. If you could have chosen this option, it is a perfectly correct answer. I hope you understood this solution very well. And this is a question I was telling that the similar question appeared in our test series and also there in the booklet of ACE Academy, but only the thing is variable names are changed. Look at what is given. Consider the following syntax directed translation scheme given below. And this is a translation scheme given, and also these are the grammar given, and these are the productions given. Sorry, grammar and semantic rules are given. Grammar and semantic rules are mentioned. Okay, these are grammar semantic rules. The question is, the S dot value for the root of the parse tree for the input 10 hash 011 is. And it is a straightforward question. It is a binary to decimal conversion. And in binary, 10 is called 2 and 011, it is called 3 by 8 because 3 digits are there. This is 2.3 by 8, 375. This is going to be the answer. But how we have to do it? This one you have to do it by constructing the parse string. Okay, we'll do it by constructing the parse string. What is the input? 10 hash 011. We have to construct a parse tree for this. S tends to S hash I. This is a production. I is hash is already derived, and with S we have to get 10. S is I hash F. Okay, I hash F. We'll make a correction. What is the S production? I hash F. I hash F. Hash is derived with I, we have to get this 10. To get 10 with I, we have to use I production. I tends to IB. I tends to IB. And because 2 digits only, 2 input symbols to be derived, I tends to B, and this B should be 1, and this B should be 0. So 10 hash is derived, and 011 is required using the F. F we have a production, F tends to BF. F tends to BF. So F tends to BF. Again F tends to BF. F tends to B. And this B is 0. This is 1. This is 1. Now we have to evaluate the semantics on the parse tree to find S dot value for the root of a parse tree. And it is given B tends to 0 says B value equal to 0, B tends to 1 says B value is 1. Right. B tends to 1 means it is 1, here 1, B tends to 0 is 0, B tends to 0 is 0, B tends to 1 is 1. Here I tends to B has a semantic rule. I tends to B has a semantic rule, I value equal to B value. I value equal to B value is 1, right? And here F tends to B. F tends to B has a semantic rule. F value equal to 1 by 2 B value. 1 by 2 B value. So this is 1 by 2. B value is 1. 1 by 2. 1 by 2 means 1 by 2 into 1 is 0.5. Next. F tends to BF. F tends to BF has a semantic. F tends to BF has a semantic. F value equal to half of F value plus B value. F value plus B value. Half of. Look. 1, B value is 1 and F value is 0.5, this is 1.5, half, 1 by 2 means what actually given? 1 by 2 of F value plus B value, means 1 by 2 of 1.5. 1 by 2 of 1.5 is equals to 0.75, that's it, na? 0.75. Again, F tends to BF. We'll have a what rule? 1 by 2 of F value plus B value, means 0.75 plus 0. That is 0.3325, correct? Sorry, 375, 0.375. And here you look, I tends to IB. I tends to IB has a semantic rule. I value equal 2 into I value plus B value. 2 into I value. What is I value? 1. 2 into 1, 1 plus 0, 2. Now what is S value finally? What is the semantic rule given? I value plus F value. I value is 2 plus F value is 0.375. That is 2 plus 0.375 is 2.375. So what is actually the semantic rule is written for? Semantic rule is written for the conversion of binary to decimal conversion, because input is 10 hash 011 is given. Actually this is an input. In binary we can call 10.011. When you convert into decimal, it is 2.375. That is a semantic rule mentioned. So answer for this question is 2.375. And these are the questions come from the compilers. And again, I can repeat it, that whatever the questions have come, and mostly of the classroom notes questions only, and all the questions except live variables, because lack of practice of the many students maybe didn't do this question on live variables. Except this, all questions are very easy questions. And these are the analysis of both databases and compilers. In next, one more faculty is going to come and explain his subject questions and explain about the weightage analysis and easy or tough of that particular subject. Okay, hope you have enjoyed and enjoying. Stay tuned, another faculty is going to come. Thank you.
Okay friends, welcome back, and we'll continue discussing this memory based question for 2023. The topic that I'm taking in this case is data structure, and as I can say that whatever the way we have covered the class, whatever the class was progressed, and whatever the way we have learned the subject, the questions were around that only. So if you have really followed the class, you will be really benefited, and I believe that you will be able to solve the question for this particular topic. Analysis wise, programming was one question which is not expected, but yes, these are all our values. Only one question, and that is also 1 mark question. Data structure, 3 question, 1 mark, and 3 mark. So the weightage of the programming has been shifted to, in this case, is data structure. Algorithm, 1 question 1 mark, and 2 question 2 mark here in this cases. And the only challenging question I think you would have found is the question from the hashing. Okay, so hashing questions was a bit asked in more detail, actually, a theoretical question. So that was a bit tough. Otherwise, I think that you find the question very easy. Coming back to this question, questions over here, and these are the memory based question. So this is one question which is like this: a single linked list delete operation. So there are 2 lists, single linked list delete operation, SLL and DL, and in this case is DLL, doubly linked list delete operation. Options I have not arranged in this way, but the question was related with the complexity. So here a single linked list delete operation, and you are given a pointer to the head also, pointer the node to be deleted also, that is given. We know that for a delete operation, what we need to do here in this case is this: if you want to delete a particular node from the single linked list, then what you need is that you need a pointer for the previous node. That is the problem here in this case, is previous node. You need the pointer for the previous node. But now the linked list is a single linked list, so you cannot go backward. But a pointer is directly given to you, node to be deleted, but still you cannot go backward. But the idea is that rather than deleting this particular node, you delete the next node. Okay, you copy the value here. You copy the value here, this value you copy it over here and delete the next node. So if you are doing this thing, that you copy the value, next value over here and delete the next node, this strategy can work, and in that particular case you can do this operation in order of 1 time. But there is a small exception, and the exception in this case is the last node. If you want to delete the last node, then you cannot take the copy and you cannot copy the next value, because there is no next value, simple here in this cases. Okay, so if you talk about entire scenario, okay, if you talk about entire scenario, then in that particular case, in that particular scenario, all element deletion cannot be done in order of, all element deletion can be done in order of 1 time except the last one. Okay, but overall, if you have to consider all the time, for that time will be also considered, and in that case we'll go here in this case is order of n, considering each and every element to be deleted. Doubly linked list, there is no issue. Doubly linked list, there is no issue. You can go backward, and that particular deletion operation can be for doubly linked list. SSL DLL, okay, SSL DL delete operation can be done in order of 1 time for all other cases except the last. Okay, all other cases it is order of 1, and DLL operation can be done because you can go always backward. In that case you can do, in this case is order of 1 time. Now right now if you remember the option, then well and good, and if you, because I do not have this option with me, so I cannot really comment on this, but this question was there, and this is the exact complexity, and this is the worst case. Okay, so order of n, I'll go with this for the linked list, considering all the cases, because it is not any specific case, we need to consider the last one, order of n. and order of 1, DLL is a constant time to delete, it takes constant time to delete the operation. Okay, so if you remember the option, then just check your answer that what you have done, and otherwise this is the best time. That is the upper limit in this cases, that order of n and order of 1. Now this is another question, that is elements are given, elements are arranged in an array A1 to A10, and which of the following represent the max heap. So now a very simple question, max heap question, and for that you need to satisfy and you need to check everything in this all the 4 diagram. Like here in this case is 23, 17, 10, and then 6, 13, 14, 6, 13, 14, and in this case is it's a max heap, so 23, 17 and 10, 6, 13, 14, this is not the correct answer. 23, second option, 23, 17, 10, and then 6, 13, 6, 13 up to this is okay. And then we have 1, 5, 7, 1, 5 and then 7. This violates this option B in this case is 1, 5, 7. This is not a max heap property. So 23, 17, 14 and then 7, 13 and then 10 and then 1 and then 5, 6 and 12. So in this case we'll go here, in this case is option C. Option C is your correct answer for this particular array, which represent here in this case is a max heap. These C things can be here and there, and please you have to bear because these are memory based questions, these are not actual questions. We'll again discuss and we'll rectify if there any mismatch or discrepancy, then definitely we are going to update later. But right now this is memory based, so we'll go ahead with that only. Next question is again from the heap operation, where extract max and insert operation. Extract max, which is actually extracting the maximum element as well as doing the delete operation, and another was your insert operation. Insert operation. So in that case also insertion is also is done in this case, and the question is related with time complexity, that both take log n time. Extract max take order of n, log n, and log n and order of n, and both takes order of n time. In this cases exact options are not there, but yes, that was something. But in this case it can be guaranteed that for deletion operation is also required adjust, so that can be also done in log n time, and insert operation can also be done in the log n time. So both can be done in log n time. That is the correct answer for this particular question. When actual question will come, again we will see whether this statements and the options are correct or not. This is one question which is from stack and queue, and let's see here. A0 is 1, 5, 7, 8, 9 and 2. S is the stack and Q is the queue. And the following operation is performed: push A0 to A5 in stack. So now we are pushing A0 to A5 in the stack, and that means we are pushing 1, 5, 7, 8 and 9, 8, 9 and then 2 in the stack, and pushing A0 to A5 in the queue. So same value, but again 5, 7, 8, 9 and 2. Then pop element from Q. Okay, fine. So here pop element from S. Okay, one statement is missing, that pop element from S and pop element from Q. Again pop element from S, pop element from Q. So if you pop one element from S, what will come out? 2 will be gone, and here 1 will be gone for Q. This is the state number 3 and 4, ordering you may change. Pop element from S, so 9 will be gone, and pop element from Q, so this 5 will be gone. Then delete element from Q and push in S. So now here 7 will be deleted and it will be pushed here. So again let me draw the S, that it will be 1, 5, 7, 8, and now 7 will be deleted and again it will be pushed. Then repeat the above operation 3 times. So 3 times again you are going to 8, 9 and 2 DQ, okay, delete the element from the queue and push it. So 8, 9 and 2 will be pushed again. So 8 will be pushed, 9 will be pushed and 2 will be pushed here in this cases. 3 times. So DQ from Q and then push and repeat the operation 3 times. Then 2 times pop the element. So now if you pop the element 2 times, 2 will be gone and 9 will be gone. The top element of the stack, so in this case the top element of the stack will be, in this case will be 8. 8 will be left in the stack. Okay. So considering this information, the answer for this particular question is 8. 8 is the answer for this question. So that is the question that is here for the memory based question that has been collected from various different sources based on the memorization. Next is a question from programming. As I told you, question from the programming, and here this is the one question where the conceptually it is talking about only a static variable. And we know that static variables initialized only once and preserve the value. So x equal to function p. What will be the function p? Value will be 2. Y will be what? Y it will be 2 because you are getting it incremented, x plus plus. So y will be what? X will be equal to 2. Y will be again calling of the function. So this time this will return the value 3. And already 2 is there, which is this. So 3 plus 2, that is equal to 5. What you need to print here in this case is x plus y. Answer will be 7 in this case. Okay. So static variable preserves the value, and in this case here first time it will return the x plus plus, second time it will be not initialized. That is the only simple concept. And I believe that everybody, whenever you learn, and it is always said that this external variable static, previously also there are a lot of questions, and this year also the same concept has been exploited in this case. So 7 is the answer for this question. This question is not a complete question, but the code snippet was given to you and ask about the activation tree for this. Okay, and this is the sort of 3 function, main function, and then f1, f2 and f3. This function was given to you and it has been asked you to compute the activation record for it. So let us compute the activation record here. Main first, control will go to main. Main is calling what? Main is calling f, and f function is just return immediately. So this is the f1. Notice here that f2 call with the parameter 2. So now you are calling f2, and within f2 the first thing you are calling is f3. F3 is also just a return value, and I hope that this given information is correct. F3. Then in this case the next statement is if x is equal to 1, but right now x is not equal to 1. X is what? X is right now 2. So this parameter 2 comes into the picture, which is passed here. So what it will call here? It will go to the else part and again it will call f2 one more time. But x minus 1. So now it becomes 1. F2 will call what? F2 will call one more time f3. And this time x is exactly equal to 1. That is true. So this time again, rather than calling f2, it will call f1. Now return time. F1 will return to f2. F2 will be definitely done because that is the else part and it is over. It will be, f2 will be over, and then finally f3. This. Okay. So this is the activation tree for this, and one of the option, this is not a basically, it is basically a multiple choice question, a MCQ question, and in that case I can say that this is the graph, this is the activation record, and this is the correct answer for this particular question. Now this particular question can be considered not as a part of activation record, it can be also considered in some other topics that has been taught to you, but activation record has been mentioned in many different subjects. Let's move on. Let's see the question from algorithm, whatever available here. Now, so here as per the information, consider the following function: fn is n and gn is equal to n square. Which of the following is true? And it says that fn is element of theta of g, gn, maybe g or gn. But we know that this is n and n square. Here, notice here that this here they have used the element symbol. An element means it's a belongs to. Now, theta of gn will be a set, and in this case it can be n square, it can be 2n square, but n square will be there. So definitely fn will be not a member of it, the false statement. Fn is element of greater than g, greater than omega of g. So fn is element, if I take the what is the greater function, so n square and n, omega of g will be all the function which are greater or equal to this, anything that is greater function, so that will be part of it. So will fn will be part of it, fn will be element of it, n will be element of omega of g? No, it will be not. Because when you say omega of g, that means here we are talking about all the function which is equal to n square or greater than n square. Fn is element of strictly lesser function in g, that is correct here, and fn is element of less than or equal to function in g, that is correct here. So in this case, both C and D is correct in this particular question. They are element of strictly lesser function or less than. Fn is always also part of less than or equal to n square. So C and D is the correct one here. Hi, hello, good evening. This is Dr. Dashath K, the subject matter expert of the theory of computation from the ACE Online. Welcome to the session. I'm going to provide you what is the 2023 GATE analysis on the theory of computation. After that, I'm going to provide you some of the important solutions and what are the numerical type of questions you have got it on this course. This is all completely on the memory based, so there may be missing of the data in terms of accuracy. You have to accept it, but 99.5% everything is going to be as it is what we are going to be see after the official key announcement as well as the question paper announcement. So once again we welcome you to the analysis of theory of computation in GATE 2023. In GATE 2023, as all my colleagues said, the paper is moderate. All the questions, most of the questions are here. They are straightforward questions. There is no much twist in the question. There are no combination of the multiple courses to frame the question here. Compared to the 2022, in 2023, we are seeing here, there are a lot of questions here. Straight away they have asked, seek for your answers. So that is a good thing is to happen in the 2023. As far as the theory of computation is concerned, this year we got 5 questions in the theory of computation. Its weightage about the 8 marks. Exclusively on theory of computation, it's 8 marks. If you combine 1 or 2 concepts from the compiler, in a compiler there is one particular question on the NFA with epsilon transitions. So that is also going to be the part of TOC sometimes, but we are taken our point of view that's exclusively on the compiler construction course. Exclusively on the theory of computation, we have got the 5 questions. All 5 questions, we have 3 MCQs. We have got the 3 MCQs here. And one is numerical answer type. And one more question is on MSA, multiple selection answers questions. All these questions, whatever we have here, this is on 2 questions on finite automata and regular expressions. 2 questions on this. And 1 question is exclusively on the grammar concept. It is on the grammar concepts. And 1 question we also got it on the push down automata. So there is a question on the push down automata, there is a question on finite automata, there is a question on the regular expressions, and there is also a question on the properties of formal languages. This time multiple selection answer is completely on the properties of the formal languages. And we have the numerical answer type. This is what always we have been expecting. Same question has been repeated here. Moreover, this question is also very standard question, standard answers. This is a direct question we got it this year. If you all know, yes students, you all know everything is from the classroom notes. Everything, every model, every question, whatever they are asked in the examination, which were all thoroughly discussed in the classroom itself. It may be the offline, or it may be online, or it may be hybrid model, whatever it. In all the sections, whatever we are taking the classes, even in the revision sessions also, we have got all these topics discussed into the expected questions from the 2023. In this entire discussions, whatever we have thought in the classroom and whatever we are discussing in the examinations, everything we got it to the examination. So that's the reason. And this is the 1 question on the numerical answer, that's exclusively on the finite automata. And in MCQ, there is a question on the finite automata, there is a question on the push down automata, and we also have a question on the regular expressions. And they are given the grammar. Apart from that, this is the 1 question, as I said, it's a composition of all the languages properties.
and is not asked about all the properties. He is mentioned about especially about the intersection operation for the different formal languages. So let's have a look at all the questions whatever they are asked in the examination. All the questions whatever we are going to be play here, they are all completely on the memory based. We will make a corrections once key has been released by the IIT. Just look into the first question, what is they are asked in the exam. Yeah, this is the one of the numerical answer type. There this time here more number of numerical answer type questions. One of the question is exclusively on the theory of computation. This is the question, standard question. Whenever there is a question on the theory of computation, mostly this is the only topic they usually ask it on this area. This is the find the minimum number of states in a DFA which do not accept 111 sequence, and by default the alphabet is 01. This question everyone will generally solve it, but the question is here not about containing the substring like a 1111. The standard question is here set of all strings are containing the substring 1111. But you are asking for here complementation of it. Whenever the question is related to the complementation for a language, we are already thoroughly discussed in the class. Whatever number of states you required for the containing the substring like a 3 ones, same number of states you also must use for the do not containing for the 3 ones. These 3 ones also should be consecutive. These 3 ones also must be 3 consecutive, right? So that is a point here. Nothing to worry here. Once you draw the finite automata system, that should be the by default deterministic finite automata and minimum state to DFA. Whatever number of states you are going to be have for the containing the substring of 3 consecutive ones, same number of states we also going to be used in the not containing the substring. What changes you will make? We will make the only simple change here, make every final state to the non-final, non-final to the final state. So this is a small change you are going to make it over there. Rest of the things are as it is. Don't try it. And that's what I said. So you just consider we are just bothering about here. This is the standard one containing the substring 3 consecutive ones here. Right? So this is what containing 3 consecutive ones or more. So that's what the problem has been given here. So this is going to be the 1, 1, 1. Then there is a self loop of the 0 here. This is for the 0. This is for the 0. This is going to be contained here. But what we are going to do here, we are going to just make here all final state to the non-final, non-final state to the final state. This is the small change you are going to make it. But we are also said in the classroom itself, you no need to draw all of them. When you say the substring length is equal to n, the minimum state automata is always required here n plus 1 number of states. This is the point we are discussing in the classroom itself. You no need to draw this diagram even at all, the straightforward question. Once there is a string of length n, which is always going to be take about the n plus 1 number of states. This is what you can see the difference. So I hope we all must follow the strategies whatever we are discussing in the classroom. And this is the exact diagram. This is for the containing. What we have to do here, you have to make all of them as say finals, and this should be the non-final. This is what exact diagram. Of course, it's a numerical type answer. So the right answer of this question is here exactly 4. After that, we had a question on the grammar. Even for this, they are asking for the language. They are giving here multiple choices for us, asking for here what is the language it can be generated. When you look at the language, you can slowly see everywhere the first string is going to be produced like a it can produce, B it can produce. After that, you can also take here this combination, any number of A's I can have here, or else A, B you can have here, or else you can also take the B's here, and so on. And whenever you consider this, so this is going to give you always the kind of question like no A, S, B, B, B. But this S should be replaced by the all the time by the X here. And when you substitute the X value here, you should be get a one more A or one more B. But whenever I consider this, A's must be started here, followed by any number of B's should be there. So that's the reason you cannot say always A's followed by B's, because I can also produce here B's alone or A's alone, all the combinations. So finally, if you work it on this grammar, you can say this will give you A's followed by B's. But remember, this can be also when I take down here, this is going to be like exactly 1A. When I take down here, it's a 1B. That is also directly can be produced. Whenever you take the B here, A's are absent. When you take the A here, B's are absent. In that combination, what you can do here, this is going to be just equivalent of n is greater than or equivalent to 0 and m is greater than or equivalent to 0. You just try in this way, you can produce everything whatever is going to be generated from this expression. So there are 4 options has been given to you. I just remembered about only the grammar part, what is there. So according to the grammar structure, I have just given you the what is the possibility of the answers. So this is the way to get into the answer to this particular question. After that, we had a one question on MSA. This is a straightforward question. I told you in the classrooms itself, no, properties of the formal language are very, very important topic. We are not talking about all the formal languages properties here. He mentioned all the languages properties, especially about the intersection. So look at all these options. This is a recursive language. They are closed under the intersection. And we also know that recursively enumerable languages are also closed under the intersection. And regular languages are by default closed under the intersection. The answer, what do you know? Context-free languages are not closed under the intersection. For rest of the formal languages, in the given options, intersection is by default applicable. Right? That's the reason in this MSA question, multiple selection answers, what you would notice here, this is the true statement, true statement, true statement, and this is the only false statement here. So this is for the one question they are given for the 1 mark. This is about the multiple selection answers. And this year we didn't get any question on the decidability or undecidability concepts. So this is the direct question on the properties of the formal languages. Later on, there are 2 questions here. One question is on the finite automata to regular expression translation. Some of the friends have shared this question in the communication system. I just wanted to share the diagram with you. What they are shared with me here, this is a state and this is a final state actually, and this is also one more state, and you know this is a, this is a, let's make this a B, names is not given here, it's a 0, and to here it's a 1 here, and here it's a 1, then this is the C, and there is one more state which is been connected to the missing edges here, and from here 0 also missing, and it is the 1 here. They have been provided the options for this, and we have to figure it out what is the expression. What I would say, all these TOC questions I told just apply the common sense to get the answers. We never require here any kind of procedure. As you know, the one of the option they are given here 0 plus 1, 1 into 0 plus 1 whole star. What is the best approach I told? Just look at the diagram. Look at the diagram. After that, write down members of the language. Write down members of the language. What is the first thing it will accept? It will accept 1. Later it will accept the 1, 0. It will accept here. Later it will going to be accept about the length 3 only. It's going to be take care about the 100 string, and it's going to be accept about the all ones. So they are the set of strings. If you look at here, this will give me the 1, fine. Later on, it's going to be accept about, this will give me the 10, fantastic, but it will also give the 11 string. Right? If you take the 11 string, but it will never accept here 11 string. That's the reason you can simply avoid this option. Right? So, if you look at all these options, there is a specific procedure how to get it on this. Then what is the finally answer you will get here? So, you can write the procedure called here either you can apply the ordinance theorem, or else you can apply the state elimination method. There are multiple methods you can do that, or else you can also use your basic knowledge how to get it. So, if you look at here, this is going to give the 1 here. After that, you will be having about 0. Later on, you are going to be have the 1, 1. So, this is going to be the circle, whole star. If you say, if this is the one of the option, you can easily look into this. How? This will accept the single one. Yes, it will produce. After that, 1, 0 will come here. Then you can take 1, 0. Yes, 1 followed by 0, you can have it from here. But you cannot get the 2 ones. This will never produce the 2 ones yet. So that's the reason you can consider here, this is going to be the expression you are going to be obtained in the same kind of analysis if you made it. Don't apply any kind of here, any kind of procedure is no more required here. It's just to do the simple analysis. So this is about the one of the question for the 2 marks from the concept of finite automata. Finally, there was one question on the push down automata. I'm not exactly remember the content of the question. The question is very simple, what they asked. They are given the PDA asking for the language recognized by the automata system. There are 4 options. When this machine has been designed, there are more number of A's than the B's. Whenever this machine, whatever they are given to us, if you apply the strings of them, this is going to be terminated at the final state whenever a string has got here more number of A's than the B's here. That's the one data exactly. We are also not able to figure it out, exact data question. As soon as we get the data, we are definitely going to be come back with your complete solution. So this is all about the theory of computation, what they are asked in the 2023. Once again, we'll be back to you once official key has been announced by the IIT. So this is all about the theory of computation. So stay tuned, next concepts are going to be taken care by the another lecture.
Hi students, good evening. At this point of time, the verbal ability, what we have secured so far, There are actually 3 questions, but I'm going to sort out only 2 questions. One is little bit based on mathematical calculations, and it will be handled by the aptitude faculty. So one of the questions is based on analogy, students. Frequent is to often, just as kind is to dash. It's a very simple analogical based question, students, and the options are one is cruel, the other one is mean, TYPE, kindly. First of all, students, frequently these questions have been taught in the class. You remember one of the characteristic features of analogy is based on the parts of speech. The word frequent, students, the word frequent is what we call it as, first of all, frequent practice we say, that is adjective, students. Let me just go with that. This one is adjective, students, and this can be verb also. Okay? And first of all, frequent and often both are synonyms. So this is one point that we have to remember, both are synonyms. Often, frequent, and often is adverb, students. Okay? And you need to follow the decorum when you go with the options. Like, as I said, if the main pair is noun, all should be nouns. If the main pair is verb, rest of them also should be verbs. And here it is adverb. So, adjective verb often is adverb. Kind is noun, at the same time this is adjective. To get here now, adverb we have to get it now. Cruel person, this is adjective. And moreover, both are synonyms. Cruel is antonym, so therefore this cannot be your option now. Mean is a neutral word. The midway one meaning is it is noun. Meant, it is verb also, students, like. Mean person, this is adjective also. What is what, students, now? Adverb now. What we need here, it is adverb. Noun, verb, adjective. So therefore this also cannot be your option now. Type is noun and it is verb. And what is the requirement here? It is adverb now. Therefore this also cannot be your option. And the only option is kindly. And be reminded, students, now, this is adjective also, at the same time this is adverb. But what we are looking is adverb now. Since this is adverb, so kindly is your best option in this analogical section, students, like. I suppose all of you might have attempted this answer now. Now let me straight away go with the next question, students, now. Let me just take the next question. Second one, we reached the station late and dash missed the train. This is a compound sentence, students, and options are: one is mostly, the other one is near, utterly, nearly. I think the question is very easy, students, like, we reached the station late and dash. Reached is verb, students. Late is adverb here now. We reached the station late. and it is joining another sentence now. Missed is verb here now. And what we have to look here, it is adverb we have to see now. Near cannot be adverb, students, okay? Mostly is adverb, utterly is adverb, and nearly is adverb now. Mostly means mainly. Mainly miss the train. No, it cannot be. Utterly, totally, completely, and completely miss the train, it has nothing to do with that. And what is nearly? Right, students, like now? Yes, almost, but not quite. So this is your best answer, students, like now. So you can go with the answer nearly. So there are two questions, students. So far, the memory-based questions given by some of the students, like, and there is one more question will be handled by, that is an inference-based question. It is of 2 marks, which will be handled by our verbal aptitude faculty. I hope you have got the right answers. All the best, students.
Hi, engineering mathematics, we were given 5 questions, 2 questions from calculus, 2 from linear algebra and 1 from probability. And moreover, from linear algebra, we were given 2 questions, 1 question from linear algebra that was linked with discrete mathematics. So it should be covered by concerned discrete maths faculty or engineering mathematics faculty. So we see the problem related to engineering mathematics, linear algebra. The problem is very simple. We were given 2 matrices. We were given 2 matrices. This is matrix A and matrix B. Simply observe these 2 matrices and the options are related to determinants. And just look at the options. If you interchange first and third rows, simply you will be getting the matrix B. So therefore matrix B is obtained by interchanging first and third rows. Do you people know if 2 rows are interchanged, then the original value of the determinant is multiplied by -1. So accordingly we can write det A equal to minus into det B, or det B equal to minus into det A. Determinant of matrix B equal to minus into determinant of matrix A, because matrix B is obtained just by interchanging first and third rows. So accordingly option C will be the right answer then. Just have a look at this and observe. Here actually we were not given, we don't have triple integral problem in the syllabus, but anyhow, we were given a question and it should also be answered by using simple logic only. Here dz dy dx, that means we were asked to integrate in the order z y x, means you have to integrate with respect to z first and then y and then x. Therefore, let us integrate with respect to z. Accordingly, you can choose the limits as well. So first these are z limits, these are y limits, these are x limits. So what are the z limits? Z limits. So first x limits minus 3 2 plus 3, y limits minus 2 2 plus 2, and z limits minus 1 2 plus 1, 4x square y minus z cube dz dy dx. And observe this, we have to integrate with respect to z first. So when you are integrating with respect to z first, at that time z is only the variable. Simultaneously, all other terms must be kept constants. And observe this, here when you are integrating, first of all we have to write the term as it is. Look there. Integral x limits minus 3 to plus 3, y limits minus 2 to plus 2, y limits minus 2 to plus 2, and z limits minus 1 to plus 1. And observe this, integral z limits minus 1 to plus 1. Here 4x square y dz dy dx. 4x square y dz dy dx. As you all know that z cube is a odd function. Therefore, integral minus a to a f of z dz, where f of z is odd function. Therefore, the value of the integral should be 0. Therefore, integral minus 1 to 1 z cube dz value 0. So, therefore, this would be the remaining. And here we need to integrate with respect to z right now. When you are integrating with respect to z, at that time z is only the variable. Simultaneously, all other x and y terms shall be kept constants. So, ultimately 4x square y is constant. Integral minus 3 to 3 minus 2 to 2, next 4x square y as it is, integration of dz, that is z, integration of dz is z between the limits minus 1 to 1, next order is important, dy dx minus 1 to 1. So if you replace z by upper limit, this is minus 2 to plus 2, and moreover this is replace z by upper limit 1 minus lower limit minus 1, so it is 2 into 4x square y, that would be 8x square y. So therefore minus 3 to plus 3 minus 2 to plus 2, 8x square y dy dx. Now we have to integrate with respect to y right now. So when you are integrating with respect to y, at that moment y is only the variable, all other variables must be kept constants. This statement is true only in case of evaluation of double and triple integral problems. This statement not at all true in case of evaluation of single integral problem. I mean in case of evaluation of single integral problem, when you are integrating with respect to y, at that time we should not assume other variable as constant. That statement, when you are integrating with respect to y, you can assume other variable as constant only in case of evaluation of double and triple integral problems only. So therefore, it can be written as x limits minus 3 to plus 3, here 8 constant, x square also constant, integration of y dy. Integration of y dy, you observe this, y is an odd function, therefore the value of the integral is 0. Because any variable power odd integer like y power 1, y power 3, y power 5, y power 7, so on are all odd functions only. integral minus a to a f of y dy, where f of y is odd function, therefore the value of the integral is 0. So no need to solve further, simply we can say the integration value is 0. Next two problems will be dealt by the next another faculty, my colleague Aditya, Aditya Srinivas will take over the session. Thank you.
This question is from probability. They're asking about the independent events. So they say that two coins are tossed and let A be the event that head on both sides, B be the event that head on first toss, C be the event that the head on second toss. Which of the following are true, and various options are given. So let's try to check. If two coins are tossed, the sample space, let's look at the sample space. It is head, 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 tail, tail, head, tail, tail. Now they say that A is an event that head appears on both sides. So let's create a set like this, A. From this sample space, look at that point where head appears on both sides. That is this. That is head, head. So this is what is in A. What is B? So what is B? So here they say that two coins are tossed. When two coins are tossed, what's the sample space? So the sample space is head, 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 tail, tail, head, tail, tail. Let's look at what is A. A is the event that head on both sides. So among those 4 points, head on both sides is this point, and probability of this is 1 by 4. What is B? So let's see what is B. B is the event that head on first toss. Among those 4 points, look for those points where head appears on the first toss. So that is head, head, and then head, tail. Head on the first toss, he said. And the probability of B, since there are 2 points, it is 2 by 4, which is 1 by 2. What is C? Let's see what is C. Be the event that head on second toss. Look at the sample space. Where is head on the second toss? This is 1 point, head, head. The other point is head on the second toss, he said, so tail, head. So this is A, B, C. Let's look at the options. He says A and C are independent, B and C are independent, A and B are independent. The conditional probability of B given C is P of B. You need to verify these options. It's a MSQ question. Now, how do you check whether they are independent or not? Suppose if you have two events, probability of A intersection B, if this is equal to probability of A into probability of B, then we say that the events are independent. Check this for all the events. For example, what is A intersection B? Look at this. This is A, this is B. The intersection is head, head. So write this. A intersection B is head, head. So what's the probability of this event? The probability of this event is 1 by 4. Now you also check what is P of A into P of B. If this product is equal to the probability of this, then you say that they are independent. Now, product P of A into P of B. This is 1 by 4 and 1 by 2, which is 1 by 8 The product is not equal to this, therefore A and B are not independent. Likewise, you can also prove that A and C are also not independent. Now I'll show you that B and C. Let me discuss B and C because A, B are similar, A, C are also similar, then B, C is little different. Let's analyze that case. So what is B? Have a look at what is B. B is head, 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 tail. Head, 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 tail. What is C? C. Head, head, tail, head. Head, head, tail, head. What is their intersection? B intersection C. What is their intersection? Is there any intersecting point? Yes, there is head, head. So there is one intersecting point. Let's write like this. Since there is only one point, the probability of this event would be 1 by 4. Now look at the individual probabilities. What is the individual probabilities? P of B into P of C. So P of C is also 1 by 2. 1 by 2 into 1 by 2 is 1 by 4. What is P of A? B intersection C. It is also 1 by 4. Therefore, we got a conclusion that probability of B intersection C is equal to probability of B into probability of C, meaning by they are independent. Now when they are independent, for independent events, the conditional probability P of B given C is same as P of B. Not only this, you can also write P of C given B is same as P of C since they are independent. So now which options are correct? B and C are independent and the conditional probability is equal to P of B. So there is another question from calculus where they gave a function f of x like this. Where they gave a function like this, blank page. So let me write this here. They gave a function f of x as x cube plus 15x square minus 33x minus 36. And they are asking about the local max and local min. It is so simple. First, find f dash of x and check for the stationary points. What is f dash of x? It is 3x square plus 30x minus 33 and then 0. Equate this to 0. 3 is common. X square plus 10x minus 11. Now when you factorize this, you get x square plus 11x minus x minus 11 equal to 0. Try to find the stationary points. You will get two stationary points. So let's factorize this. This is x common, x plus 11, and then minus 1 common, x plus 11. This has to be equal to 0. From this it is very clear that the stationary points are minus 11 comma 1. What next? You have to find the second derivative, that is f double dash of x. What is f double dash of x? It is 6x and then plus 30. Substitute the stationary points into this based upon the sign of the second derivative, conclude about the local max and local min. For example, if I substitute minus 11, minus 66 plus 30 is obviously negative. That means that x equal to minus 11, since it is negative, you will have a local max. And then substitute 1, it would be 36, it is positive, therefore at x equal to 1, you will have a local min. So this was a MSQ question, very simple. Next, we have a discrete mathematics faculty, Dr. Manikumar sir, going to handle the session.
Good evening, students. I am Dr. Manikumar. I am here to discuss memory-based questions on discrete mathematics. You see, we received one question on discrete mathematics like this. This is a problem based on recurrence relations. Given recurrence relation is ln is equal to ln minus 1 plus ln minus 2. Actually, it is ln minus 2. Not like this, ln minus 2. L1 is equal to 1 and L2 is equal to 3 given, means two conditions given. Now this is, you see, this is second order linear recurrence relation. Second order linear recurrence relation. So how to solve? First I have to solve characteristic equation. What is CH equation? Characteristic equation is, I will change the color. Okay. What is characteristic equation for it? CH equation means characteristic equation, that is R square. Actually say ln, you can write it as ln minus 1 minus ln minus 2 is equal to 0. So corresponding to that, what is characteristic equation? R square minus R minus 1 is equal to 0. For this given recurrence relation, this is a characteristic equation. Solve this characteristic equation, what it is? R is equal to minus b plus or minus 1 plus or minus root 2 over b square minus 4ac. That is 1 minus of minus plus 5 by 2. Sorry, plus 4 by 2. This is plus 4 by 2. This is nothing but R is equal to 1 plus or minus root 5 by 2. These are the roots. Now, 1 plus root 5 by 2 is one root and 1 minus root 5 by 2 is the another root. Okay? Using this, okay, how to write the solution? Now, ln is equal to, therefore, what is ln? Ln is equal to C1 into, what is one root? One of the root is 1 plus root 5 by 2. 1 plus root 5 by 2 whole power n. Plus another root is C2 into 1 minus root 5 by 2 whole to the power n. Okay. 1 plus root 5 by 2 whole to the power n, 1 minus root 5 by 2 whole to the power n. But here conditions given. L1 is equal to 1, L2 is equal to 3 given. Using these two conditions, first I have to find C1 and C2. But it is a time taking process, don't do like this. That is not smart work. So, already options given, luckily here options are available. Substitute the given conditions in options, which option satisfies, that is our answer. Now you see, now coming to option A is nothing but this one. Now I will take L1 is equal to 1 in option A. I will take L1 is equal to 1 in option A, B, C and D. Okay, verify here. What? L1 is equal to 1 implies, L1 is equal to 1 from option A. From option A. What is L1? N is equal to 1. L1 is equal to 1 means L1 is N is equal to 1 here. Ln is equal to what is option A? Actually, Ln is equal to says 1 plus root 5 by 2 whole power n. 1 plus root 5 by 2 whole power n plus 1 minus root 5 by 2 whole power n. Okay. But L1 is equal to 1. L1 is equal to 1 means here this is 1, L1, n is equal to 1. Substitute n is equal to 1. So L1 is equal to 1, LHS is 1, RHS 1 plus root 5 by 2 whole power 1 plus 1 minus root 5 by 2 whole power n, 1. Now you see this, root 5 by 2 and minus root 5 by 2 both will cancel. 1 by 2 plus 1 by 2 is equal to 1. It satisfies or not? Very clear. Option A satisfies for L1. Actually, you have to verify L2 also. But again, you think smart. Okay, even if you verify L2, again, it is a time-taking process. Don't do like that. So, verify L1, say this. Now, coming to the, you can ask, you have some doubts. Maybe option B and C also, C, D also may be correct. But you see carefully, already for L1, option A is satisfied. But in option B, here minus is there. See, here, these two terms are same, minus is there. Definitely, L1 will not satisfy. Even option C also, here minus is there and along with 3 also there. Definitely option C also fails. And think smartly, even option D also 3 is there. Definitely option D also will fail. Means L1 satisfies for option A only. Why unnecessarily verifying L2? So option A is correct. Are you clear? Now, and one more question we received, that is memory based question. Actually one graph given to you like this. This is one undirected graph given like this. This is 1, 2, 3, 4, 5. This is undirected graph. For 3 and 4, self loops given actually. For 3 and 4, self loops given like this. For vertices 3 and 4, self loops given like this. Now, you have to write the adjacent matrix for it. For the, okay, for eigenvalues at totally how many vertices are there? 5 vertices. 5 vertices means we will get one 5 by 5 square matrix. We call it as adjacent matrix, you have to write the adjacent matrix. Okay, 1, 2, 3, 4, 5. And here also 1, 2, 3, 4, 5. Now, you write the adjacent matrix, adjacency matrix corresponding to the given graph. Now, 1 to 1. 1 to 1 means very clear. If any self loop is there, then you can take one. No self loop means 1 to 1, 0. Between 1 and 2, 1 edge is there. 1 to 2, 1 edge is there. 1. Between 1 and 3, no edge is there. 1 to 3, no edge. 0. 1 to 4, no edge. 0. 1 to 5, no edge. 0. Now, between 2 and 1, 1 edge is there. Between 2 to 3, 2 to 2, no self loop. 2 to 3, 1. 2, 4, 1. 2, 5, no, 0. Now coming to 3, 1, no, 0. 3, 2, no. 3, 2, yes, 1. Okay, 3, 3, one self loop is there. Now, 3, 4, between 3 and 4, no. 3, 5, 1. Next, 4 and 1, between 4 and 1, 0. Between 4 and 2, 1. Between 4 and 3, no. 4 to 4, one self loop is there. Yes. 4 to 5, one edge is there. Between 5 and 1, 5 to 1, 0. 5 to 2, 0. 5 to 3, 1. 5 to 4, 1. 5 to 5, no self loop is there. Now, see, actually in the given question, the information what they have given, suppose a lambda 1, lambda 2, lambda 3, lambda 4, lambda 5 are the eigenvalues. Actually given data is lambda 1, lambda 2, lambda 3, lambda 4, lambda 5 are eigenvalues of capital A. Capital A means this is the adjacent matrix capital A. Then what is the sum of all eigenvalues given? Already you know one property in eigenvalue. Sum of all eigenvalues is nothing but the trace. What is trace here? Trace is nothing but the sum of all principal diagonal elements, that is a trace. Okay, this is sum of all eigenvalues is 1 plus 1. But one more small information, one smart information. By default, generally, principal diagonal elements are nothing but the elements from self loop, means the number from self loop only. How many self loops are there here? 2 self loops. 2 self loop means 2 ones will get, remaining all will be zeros only. No need to take a matrix like this. How many self loops are there? Just you add that number of self loops, that is a final answer. 2 self loops means 1 plus 1, 2 is the answer. No need to do like this also. Now sum of all eigenvalues is nothing but a trace. Lambda 1 plus lambda 2 plus lambda 3 plus lambda 4 plus lambda 5, that is nothing but trace. What is trace? That is finally 1 plus 1, remaining all are zeros, 2 is the answer. These are the 2 questions, memory based questions we received on discrete mathematics. I hope you all did well.
ACE Engineering Academy welcomes you. This is YV Ramaya, faculty of ACE Engineering Academy, and especially for COA and digital subject. According to the information collected from the students, we are going to discuss 3 questions from these 2 subjects, especially when we consider the weightage of these 2 subjects compared to last year, before last year, or 2010, 11, 16, 17, like that. Here, combination of these 2 subjects weightage is unchanged, because last year on COA subject we had 11 marks, from digital subject only 3 marks, in total 14 marks. This year what happened? From COA subject we got 7 marks, only from digital subject we got 10 marks, total 17 marks. Means minimum weightage of combination of these 2 subjects is 14 marks. Not only this year, last year, before last year, like that. So these are purely memory based questions. We have collected this information from our beloved students who have written the exam on today. Next, official paper will be released on 15th of this month. Later, we are going to discuss each and every question in elaborate, clearly. First of all, subject computer organization and architecture, just only memory based. Here, 3-stage pipeline processor having delays of 10 nanosecond, 20 nanosecond, and 14 nanosecond for the first, second, and third stages respectively. He mentioned the stage delays 10, 20, 14 nanoseconds. Next, without any additional delay or hazard. Means while executing a program, no additional delay is there, no hazard will be occurred. Assume one instruction is fetched in every clock cycle. Means program means sequence of instructions. For fetching one instruction, only 1 clock cycle is sufficient. The total execution time of 100 instructions is dash nanoseconds. He asked the value in nanoseconds. It is NAT. Now, in this, first you find the segment delay time. It is nothing but the one of the longest delays, nothing but 20 nanoseconds. At the same time, K value is equal to 3. K means number of stages. N means number of instructions to be executed 100. It is moderate question. It is moderate question. Here, amount of time needed to execute. Amount of time needed to execute on pipeline processor is nothing but K plus N minus 1 into T segment. In this, K plus N minus 1 is nothing but 102 into T segment is nothing but 20 nanosecond, nothing but 2040 nanosecond. Already he mentioned nanosecond here, so answer is 2040. It requires 2 minutes explanation, but only 10 seconds explanation is also there. In the stage delays, what he mentioned, first you find the longest delay, 20 nanosecond. It is nothing but 1 segment delay. Next, at the same time, number of instructions is nothing but 100. K value is equal to 3. So K plus N minus 1 is nothing but 102 without using calculator. 102 into segment delay is nothing but the one of the longest delays. 102 into 20, 2040 nanosecond, 2040 nanoseconds. Okay? We go for discussing next question. Look here. This question belongs to cache memory. Cache size is 64 KB. Next, where KB is equal to 1024 bytes, PI is equal to 32 bit, associativity is equal to 8. Find out number of bits in tag. He asked the tag field size. Truly speaking, this solution also does not require any calci. Only 30 seconds time is sufficient because we had solved so many such type of questions in our physical class, online class. Okay. in this technique is like this. Cache size is 64 KB, means 2 power 16 byte, and PA, physical address size 32 bit. Next, associativity 8. In this, word size is not given. Default word size is 1 byte. Now at the same time, the expression for a tag field size is PA minus CA plus log n with base 2 PA, physical address size, number of bits required to select one of the words from the main memory, already he mentioned clearly. Next, CA, cache address, means number of bits required to select one of the words from cache memory. It is nothing but CA is equal to 16, because cache memory is having 2 power 16 words. Here one word is nothing but 1 byte. So number of bits required to select one of the 2 power 16 words is nothing but 16. So from these two we get 16 plus, here n means associativity, means number of blocks in one set. That's why here already he mentioned 8, means log 8 is nothing but 3. Answer 19. Here, without using calculator, simple explanation is like this. Already he mentioned PSI is 32 bit, CA with the help of this 16, 32 minus 16, 16 plus log n. N is nothing but associativity. Log 8, 3, 16 plus 3, 19. Calci help is not required. It is also moderate question. We had solved so many these type of questions in earlier sessions. Come to next question. Convert 132 in base 4 number system to base 5 number system. In this, I am going to write the question in our style. This question can be discussed in either COA subject or digital subject. He asked this value. First of all, 132 base 4. Find its decimal value. For finding the decimal value, 4 power 0, 4 power 1, 4 square. Already we know expression. A into 2 power I. I value range is from 0 to n minus 1 for binary system. If it is base 4 system, in place of 2, we can write simply 4. Same procedure. From this, we get, in decimal we get 16 plus 12, 28 plus 2, 30 in decimal. Convert the same thing into base 5 system. In this, 30, 5, 6, 30, remainder 0, 5 ones, 5, remainder 1. Collect the remainders in this order. So our answer is 110 with base 5. So for this question, our answer is 110. We have collected some more information regarding multiplexer, but only some information, not full information. That's why we are not interested to discuss that one in this platform. That's why next subject will be continued. Thank you very much. And I hope all of you have performed well.
Hello my dear friends, let us go ahead with the numerical ability questions. So this is the question given based on Fibonacci series, which is familiar for computer science aspirants. So they given f of n plus 1 is nothing but equal to f of n minus 1 plus f of n. This is what next number is obtained by adding previous two numbers. That's what Fibonacci series, right? Next number is obtained by adding previous two numbers, right? Here in question f6 and f7 is given, you need to find f1. f6 is there, f7 is there, you need to find f1, right? You need to go for first one. So what I do, so I agree that okay, adding present two numbers will give the next two numbers, right? Now I want previous one. See, one simple trick what you can do is f6 is given as 37, okay, f7 is 60, f6 is this, f7 is this. I can find f5 by doing subtraction of this. Adding these two will give next, subtracting these two will give previous, right? Simple point. So 37 and 60, the difference is nothing but 23. f5 is 23. Then f4 will be obtained by taking difference between these two, which is 14, right? Then similarly, f3 can be obtained by taking difference between these two, which is nothing but 9, and f2 will be obtained by taking difference between next two, which is nothing but 5, and f1 is difference between these two, which is nothing but 4. So they're asking what is f1. They can ask f2 also. f1 is 4, okay, f2 5, like that. The question given is you have to find f1. So f1 is nothing but 4. They given the options, okay, don't worry, they given options. f1 is nothing but equal to 4. Okay, Fibonacci series, adding previous two numbers will give the next number, right? So this is the simple way of solving. Okay, subtract previous number, again subtract these two, previous number will obtain, subtract these two, previous. That's the easy way of doing the question. See the next question, my dear friends. This is based on percentages, inferences. The given data, you need to go through the entire data. Finally, what can be inferred from this data? The given options, we need to see which is correct with respect to the data. Okay, now if you read the question, a survey of certain year found that 90% of pregnant women reused, okay, medical care at least once before giving birth. So they go for medical care at least once. They are going for medical care at least once. 90% of pregnant women. Suppose pregnant women are 100, pregnant women are 100, 90% of them means 90 people. Okay, pregnant women's total 100, among them 90% means, okay, 90 people are, okay, going for medical care. Among those 90 people, see, of this means among those 90 people, 60% of them, okay, are received care, medical care from doctors. So among this 90 people, among 100 pregnant women, 90 people only going for medical care. Among those 90, 60%, 10% is 9. 10% means removing 1 0. 10% is 9, 60% is nothing but 54. So this, 54. 54 pregnant women are taking help from doctor. Okay, out of 100, 90 only taking the medical care. Among 90, 54. Okay, what about remaining 40% is taking, okay, health care from other sources, right? So from other sources, okay. Now we have to see remaining 40% means 36 people, okay, 36 women are taking, okay, health care but from other sources. Taking help of the doctor for the health care is 54 people out of 100. Now see, this is the numeric point of view for this entire data. Data entire we dumped into numeric value. Now see this, less than half of the pregnant women received medical care at least once from a doctor. From a doctor, 54 people, it's not less than half. 100, half of that is 50. We got more than half, not less than half. So option A is wrong. Next one, B is more than half of pregnant women received medical care at least once from a doctor. More than half of the people, yes. Out of 100 pregnant women, okay, more than half, 54 is more than half, are taking, okay, received medical care at least once. Yeah, here they given, see, at least once they are taking medical care before giving birth. Yeah, second one correct. Option B is correct. So what about option C? If you go through option C, less than half of pregnant women taken medical care at most once from a doctor. First of all, less than half is wrong. Okay, pregnant women taking help from the doctor is more than half. That's wrong. And other thing why it is wrong is at most once. At most means maximum one time. Here the entire data is related to at least once. At least they have to take medical care once before giving the birth. But here at most once they given, that's wrong. Okay, this is not related to this information. We cannot infer C and D. B is the correct inference or correct conclusion for the given data. Okay, they didn't mention what is the total number of pregnant women. It may be X or it may be 100. I assumed 100 and we proceeded. Or you can take something X and also you can proceed. With value you can understand things better. That's why we converted into value. Right. Now see the next question, my dear friends, related to functions. Okay, previous GATE papers also, if you refer GATE 2021, 2022 or 2020, they define some function and they'll ask questions related to that function. You can find, okay, the question here also is similar to that. F of t is a function which is given as 0.01 t square. G of t is defined as 4t, and both of these are valid when t value is between 0 and infinite. T value is a real number from 0 to infinite. You can take any value from 0 to infinite value. Okay, f of t, g of t is there. Now with respect to these two functions, they are given two statements, which is correct, which is false, we have to decide. First statement is, for some t greater than 0, g of t is greater than f of t. This is not for all values, they are not mentioned. This is only for some values, not for all. All means they will give symbol like this, for all value of t greater than 0. But they are given some, not for all. This is for only some value of t. This is not given for all, they are given for some. So for some value of t greater than 0, g of t greater than f of t, is it correct or not? One case at least you see, g of t greater than f of t, t must be taken in positive. Right? So guys, if you take t value 1, you can see statement 1 is true, because for t value 1, g of 1 is 4, whereas f of 1 is 0.01. So clearly g of t is greater than f of t for a particular value, t value 1 I taken. You can take t value 2, 3, different things. I am showing you one case where that is true. So first one is true. Okay, not for all values, they didn't ask for not all values, they are asking for some values of t. Next one also correct, second one also correct. There exists a t such that f of t greater than g of t for the t value. Okay, they are asking, okay, t, there is a value t, f of t must be greater than g of t in this range. You do statement 2 also correct. Let's take t value 1000 here. If you take t value 1000, f of t if you calculate will get 10,000. You substitute t value 1000, 10 cube. 10 cube whole square is 10 power 6 into 0.01 is 10 power 4, which is 10,000. Whereas g of t will be 4,000 only. Clearly, for this particular value of t 1000, you can take different values and try. I am just giving you a sample value. For t value 1, first one true. For t value 1000, second statement also true. Okay, if they mention for all means both are wrong, but there exists a t such that yes, this is correct. Both are correct. Both statements are correct, my dear friends. I am just checking your responses, or anyone putting any doubts. I am just and no issues. Okay.
Now, 1 plus root 5 by 2 is 1 root.
One second, sorry.
Root 5 by 2 is the
Fine. So, okay. 5 to all elements, t greater than 2, statement 2 always true. If suppose if it is for all, my dear, okay, Avinash, that's what. We don't have the exact questions, right? This is all memory based questions. If they mention for all t, please make sure if this second statement is for all t means wrong. Second one, I'm repeating that. Okay, the question is like this, then your answer should be both. Okay, we are not sure the questions will be exactly like this, right? This is memory based questions. If suppose, okay, they mention for all value of capital T, means okay, then second one wrong. It's not for all value of T. This both is correct only for some value of small t or for some value of capital T. For that case only. Okay, if they mention for all means it's wrong. Both are wrong actually. For all value of T, wrong. This is also for all value of T means wrong, dear. Okay, if question is like this, then we can go with both. If they mention all, we cannot go ahead here, right? And my dear friends, see, they given questions related to series as well, but we didn't get the exact question. Okay, series questions also they given. They given questions from spatial aptitude part as well, but we didn't get the exact question, so that's why we are not focusing on that or not discussing that. But just to give the idea, they given a question from series, they given a question from spatial aptitude. Okay, and they given base system question also. Okay, converting that base. Okay, for computer science students, this will cover in digital electronics as well. Base systems also they given. Series, number series related question also given. Spatial aptitude question also given. Okay, base systems also given. Right, so the questions related to aptitude are very easy and moderate, not difficult questions. This is also easy general question. This is from percentages, basic thing. And this first question, Fibonacci series, as computer science aspirants are very familiar with Fibonacci series, you can do things better, right? Fine, so hope you understand, guys.
So guys, it's time to discuss for computer network question. So this GATE paper, we can take it as from easy to moderate level computer network questions, right? So what I remember, I had taken in a memory based format. It may not be exact, but closer to exact, okay? One more thing guys, this time
GATE people have touched almost 2 questions from network layer, 1 question from transport layer, 1 question from application layer, right? This is what I have remembered. So let's start the game, guys. Let's start the question. Let's start seeing the question and try to solve those questions. Whatever question asked in our GATE 2023. The first question. Again, this question was more or less based on the network layer, on the routing protocol concept. The entire theory, I believe this is the exact question which have been discussed in our recorded video session. So if you see what they are asking, which of the following is incorrect for OSPF, which is the routing protocol only, which work in an autonomous system, So first of all, the question becomes, sir, what is autonomous system? The point is, guys, all these things have been discussed. So autonomous system is nothing but, you can take it as a system in which a group of network or a group of routers are working under a single authority, okay? Now, let us say here some routers are there. They are working under this autonomous system. Now, whatever the protocols, whatever the set of rules we are implementing inside this autonomous system, that is named as intra-domain protocol, intra-domain, within the system. And whatever the protocols work between the autonomous system, we named it as inter-domain routing protocol, right? So this is intra-domain for sure. And whatever the protocols we are running between the autonomous system, it is inter-domain. Inter-domain. Cool. Now, sir, what are these intra-domain? So for that particular reason only, we have seen one beautiful chart, okay? So let me show over here. We have seen in the recorded video all these things ditto as it is present. Routing protocols classified in 2 types, intra-domain, inter-domain. Okay. Now, in intra-domain, we have studied RIP and OSPF. If you remember, this protocol, the people are asking about this protocol only. So first thing is for sure, sir, it is an intra-domain protocol. For sure, this is an intra-domain protocol. Now, in the inter-domain protocol, need not to go because they are not asking, but just for knowledge purpose only. Path vector routing protocol, the implementation is BGP. Okay. So BGP works over here. Now, over here in intra-domain, we study RIP, we study OSPF. So now, this RIP is an implementation of your distance vector routing. OSPF is the implementation of link state based protocol, LSP. Okay. One more thing, guys. This distance vector routing more or less uses the Bellman-Fold algorithm, more or less closer to Bellman-Fold algorithm. This LSP uses Dijkstra. It uses Dijkstra algorithm. So now the entire concept is clear in order to solve this particular question. What the question is saying, which of the following is incorrect for OSPF? It is based on Dijkstra. Yes, this is true. This is not incorrect. This is true. So option A is true. It is a hierarchical protocol. Yes, this is also true. Actually, OSPF is a hierarchical protocol. Let me give you a hint why we say so. Because let's say this router wants to communicate with this router. Then the protocol says that, OSPF says that we need to communicate first the whatever the router present on the border. Then this router will communicate the another autonomous system router which is present at the border, and then your packet will be delivered inside another autonomous system. So that's why they are hierarchical in nature. They follow the hierarchical path. So that's why we say it is a hierarchical protocol. Now, it is an inter-domain? No, It is an intra-domain, that's why this is false. Based on Bellman fold? No. It's based on Dijkstra. So actually the right answer for this question is, because they are asking for incorrect, the right answer is C and D. Okay? It's a memory based question only, guys. Need not be the exact statement, but the concept is very clear. Okay? So maybe they have written here it is not a hierarchical protocol, then B is also right, because they are asking for incorrect. Now, let's see our next question. So this question, suppose the routing table is as follows. What will be the interface ID for this particular host ID? They are asking for what is the interface ID, that among this 1, 2, 3, 4, which interface ID will get selected. So many times GATE has asked this type of question, we have seen already. Without using pen also you can solve this question, because we have practiced it rigorously, isn't it? Now guys, let us see, it's a very basic question only. It just need one thing. In order to find what is subnet ID, we are going to do the AND of your host ID part with subnet mask. This is already we know. Then we will get what is our subnet ID and corresponding interface will get delivered. Now let us see what is our ID, this part. Now observe carefully, without using pen, observe carefully. Sir, first 2 octet, that is 200.150, 200.150 is same for all the subnet ID. So need not to take your pen and convert these 2 octet into binary. It will save your time, although the paper is over now. But yeah, it will be good if you solve the question like that only. 200.150. Need not to touch this part. The only thing bothers you the last 2 octet, because these two are only different, right? So let us do the math. ID. What is ID, guys? 200.150.68.118. Subnet mask. Let us start from the first subnet ID. So subnet mask for first subnet ID is 255.255.0.0. What we are having, guys? We already know anything ended with 255 is that thing only. 200.150.0.0. Yes, it matches with first subnet ID. That's why, yes, for now interface ID 1 is selected. For now it is selected, yes, for sure. Second, let's check for the second. Second says, this is the first one. Now we are solving second. The second says, again ID, subnet mask, and we will get subnet ID. What is ID? 200.150.68.118. What is subnet mask? For this 255.254.224.0. 224.0. Guys, already we have seen the entire table. 255 contains all 8 ones, right? Then 254, 7 ones, like that we have seen the entire table. So directly also we can do, if you want, I can solve here in the binary fashion also. 68 is what? This is 64. This is 68. Then the next is 224. 224 is 111, 0000. So we are having 1, 0, 0, 0, 0, 0, 0, 0, which is nothing but 64. Yes, the subnet ID here we have 200.150.64.0. So yes, again we are having the same subnet ID. That means yes, for now we have in our box first and second both. Okay, let us go for third, because here the concept applies of longest subnet mask, right? We have practiced this type of question also. Again, GATE asks the same pattern. Let us try for the third. So again, ID, subnet mask will give subnet ID. ID is saying 200.200.0.0. 150.68.118. Subnet mask, they are saying for subnet mask 255.255.255.0. So again the same thing guys, we'll copy the ID as it is because ending with 255. 68.0. Again guys, the subnet 3 also matches. This is also in our bucket list. Okay, let us try for subnet 4 because I can see it is having a longest mask. If it get matches, the answer is interface ID 4. If it is not matching, then yes, we have to go for the second last, that is interface ID 3rd. Cool. The last part I am solving it after erasing it. So again ID, subnet mask, bitwise AND will give subnet ID. This is host ID 200.150.68.118. Subnet mask 255.255.224. So for this particular, here we are having 200, here we are having 150, here we are having 68. Till now everything matches? Yes, matches. Now let us check for the 4th octet. We can't do it orally, right? We have to convert it into binary. So 118. 118 is nothing but, so 6432 is 96, 112 plus 6 is 118. 24, 224. 224, 111, and then we have 0, 0, 0, 0, 0. What we are having, this is 0, this is 1, 1, 0, 0, 0, 0, 0, 0, right? What is this? 96. What we are having? 64. Here comes the twist, guys. For the same reason, this is not selected. 4th is not selected. Now, which interface ID will be selected for this host ID? Interface ID number 3. Because it is having the longest subnet mask. Okay, we have solved such type of questions. Now guys, this is about this question. Let us see one more question. Yes, again, 3rd question. A link is point-to-point connected and using stop and wait protocol. Which of the following is correct for using lowest link utilization? So simply this question is really very simple guys. Again, I think this question was asked in 1 marks. So they are asking for the efficiency, and for this particular efficiency, which of the following option is correct? So first of all, do we know the formula for efficiency? Yes. What was the formula guys? Tx, that is the transmission time, by transmission time plus 2 into propagation time. Yes or no? Yes. Do we know the formula for this Tx? Yes, we know. Sir, why you are writing the formula? Because read out the options. He is saying low link length and higher transmission rate. Link length, not packet length. Link length. He is asking for the link length. Transmission rate. So transmission rate, we can take it as a bandwidth. We can take it as a bandwidth. By assuming transmission rate as a bandwidth, now let us solve the question. By assuming link length as B, which comes under the formula of TP, let us solve the question. So what is Tx, sir? L by B. Packet length divided by bandwidth. What is Tx? Sir, this is the transmission time only. That's why I am writing the formula L by B. Plus 2 into. What is TP? Sir, this is the propagation time only. But the formula says I am D by V. Now guys, let us do the math. Now this question is all about pure maths. No Cn. Cn gone. Cn applies in this part only. Now Cn gone. Now here comes the maths. Math says, okay, cancel, cancel, put B here. L by L plus 2dB by V. Obviously there is into. Now, what is in the denominator part? Sir, D is there and bandwidth is there. What is D? Sir, link length. Right? What is B? Sir, this is a bandwidth, and we are naming here it as transmission rate. Now, sir, this is inversely proportional to our efficiency. This is inversely proportional. We can see D and B are the denominator part. Now, sir, if these two are high, na, efficiency is low for sure. If these two are high, then efficiency is low for sure. Let us check it out. So low link length, no, they are saying it is low, option A is wrong. Low link length, no, again they are saying low, option A is also wrong, B is also wrong. Higher link length, hold on. Higher transmission rate also, yes, this is what we want. So option C is correct, okay. So guys, this is all about computer network question. We have taken 3 questions. Some more questions are coming and sir is waiting outside. So yeah guys, take care and all the best. This paper is really, I would say not very easy, but easy to moderate, okay. So yep, okay, next sir will come.
friends, now we are going to discuss memory-based questions from operating system subject which have appeared in GATE 2023. Let us look at this question. Which of the following scheduling policies causes starvation? And I know now most of you people more eager about the options or answers and the key of the question, but not on the explanation. So what I'll do, first I'll give the key for each and every question. After giving the key, I'll give you why that option is answered and why that option is not answered, like this. Fine. So the question is, which of the following scheduling policies cause starvation? Okay. So answer to this question is SJF and priority. Fine. Answer is SJF and priority. Now I'll explain you why FIFO doesn't cause starvation and RR, that means round robin, doesn't cause starvation, and I'll also explain why SJF and priority are causing starvation. Fine. So if you take SJF, let us say there is process P1, P2, P3, fine. Now process P1 has burst time of 2 and process P2 has burst time of 3 and process P3 has burst time of 10. Now let us consider a scenario where P1 gets executed and P2 gets executed. After that P4 entered the picture and its burst time is 2 only. Now based on the principle of SJF, instead of P3, P4 gets the chance. And let us extend this process. P5 is coming, its burst time is also 2. P6 is coming, its burst time is also 2. So on whatever the process is coming, all the processes are having burst time 2 only. Now look at this scenario. Even though P3 has arrived so much early, it is not getting the chance because of the implementation of SJF. You got the point, right? Now the simple point we can conclude is, if the process with less burst time are arriving into the ready queue repeatedly, then the process with highest burst time will be starved, like it waits for indefinite time. It waits for indefinite time. Okay, let us recall two things. Starvation is indefinite waiting, deadlock is infinite waiting. But convoy effect is long waiting but definite waiting. What do I mean by this? I'll explain you. Long waiting but definite waiting. Okay, based on the constraint of FIFO, whatever the size of the process, it doesn't matter. Unlike SJF, FIFO gives the chance based on the arrival time. Let us say P1 has arrived at time 0, P2 has arrived at time 1 and P3 has arrived at time 2. And let us say P1 has processing time of 100 units and P2 has processing time of 2 units and P3 has processing time of 3 units. If you observe here, P2 has to wait for long time, that is 100 units of time. But there is a guarantee that after 100 units of time, P2 will get the chance. After completion of P1, P2 will get the chance for sure. But in case of SJF, after completion of P2, there is no guarantee that P3 will get the chance. P4 may arrive or P5 may arrive or P6 may arrive. This is what making P3 not getting the chance. You got the point, right? So in FIFO, convoy effect is possible. Even though long waiting is there, that is a definite waiting. So it is not suffering from starvation. So convoy effect is there, but starvation is not there. But in SJF, starvation is possible. So in case of SJF, because of the burst time, starvation is happening. If you consider these as priorities and consider lowest number priority as lowest number has highest priority, and this 10 least priority because 10 is the highest number. You got the point, right? Now we are not considering these as burst times. Now we are considering these as priorities. So whichever the process has low priority number, it gets the highest priority. That means P1's priority is high and P3's priority is low. Fine. So now similar to SJF, here also what happens? P3 never gets the chance because there are some processes whose priority is 2 or keep on arriving in the ready queue. So all other processes will get the chances, but P3 will not get the chance. So here also there is chance for starvation. Fine. In case of round robin, starvation is not possible at all. Why? After each quantum, some other process will get the chance. Like let us say if the time quantum is 2, process will get preempted after 2 seconds. Then process 2 get the chance. At time 4, that is after 2 seconds, again P2 will get preempted and P3 will get the chance. After 2 seconds at time 6, now P3 will get preempted and P4 will get the chance. So every process will get a fair chance. That means here also no starvation. Fine. Hope you got the explanation. To conclude this, which of the following scheduling policies cause starvation? That means SJF and priority will get starvation. Fine. Then next question. Which of the following will guarantee the computer system transition from user mode to kernel mode? Fine. The answer is page fault and system call. This is the answer. Fine. Now I'll give you the explanation why these two are causing transition from user mode to kernel mode and why other two are not causing. See, if you know the definition of system call, it is a request to kernel. Okay, requesting service from a kernel is called a system call. So by the definition, system call is talking to kernel. That means the transition from user mode to kernel mode is needed. You got the point, right? By the definition, system call is request to kernel. Fine. So then there is something called interrupt. So interrupt is an event which halts the execution of current program and gives and transfer the control to the kernel. You got the point, right? So let us say in case of page fault, the system knows whatever the page it needs, it is not part of the main memory, and it creates a disk interrupt to get the page from the secondary memory. So since it is creating a disk interrupt, this fault will create a system call. Got the point, right? So system call is a request to kernel mode, and this page fault will cause a system call. So it is also moving to kernel mode. What about normal function calls? Normal function calls doesn't need help from the kernel. Fine. Normal function calls doesn't need help from the kernel. And this is a generic term, function call. And malloc is one of such functions. That means malloc is also a function call. But there is a debatable point here. What is that? Malloc will call either SBRC or mmap. These are system calls. But the point is, malloc will not always cause a kernel mode transition. Malloc will not cause kernel mode transition always. There is a possibility that it invokes the system calls. But the thing is, it is not always. But what it is asking? Guarantee the transition. That means, since even though there is possibility of malloc to invoke a system call, it is not guaranteed always. For that reason, because of this guarantee word, we are not including malloc call. Got the point, right? Even though it is debatable that malloc also involves some system call, but it doesn't happen always. It may or may not happen. For this reason, we are removing malloc from the choice, our answer. Fine. So malloc and function doesn't involve transition from user mode to kernel mode, but page fault and system call involves the transition from user mode to kernel mode. Fine. Next we are going to see a numerical. See this question. Consider a computer system with 57-bit virtual addresses. Fine. Single level page tables with L levels for virtual to physical address translation. The page size is 4 KB. Fine. So virtual address space is 57-bit and page size is 4 KB. And page table entry size is at any level is 8 bytes. What is the value of L? So they are applying multi-level paging. They are asking us how many number of levels are required. Fine. So I remembered all the required data. Now I'll write a concept here. Just understand this. To calculate the page table size, okay, our formula is hash pages in that level, that number of pages in the level, into page table entry size. So with this, we calculate the page table size. Okay. When we'll stop the process of paging? If our page table size, that is PTS, is less than page size, then if page table size is less than page size, then stop the process of paging. Then stop the process of paging. This is the concept we are going to use here. Fine. If you remember, it is a 57-bit virtual address space. Fine. And they said 4 KB page size. 4 KB means square, that is 4, and K is 2 power 10. That means 2 power 12 bytes. That means the page offset needs 12 bits. After subtracting this 12 from 57, 45 bits are left for page number. That means our process contains 45 different pages. Fine. Now, at level 1, I have 2 power 45 different pages. Fine. At level 1, I have 2 power 45 different pages. Each page can contain. Now what I am calculating? My process size is 2 power 45. Now I am calculating number of pages needed. It will be 2 power, 1 minute. Sorry for this. Sorry for this. So, let me take the eraser from here. Fine. Okay. Now, the page number contains 45 bits, right? So, number of pages is 2 power 45. What I told you, page table size is, that means PTS is number of pages into page table entry size. That means page table entry size is 8 bytes, if you remember. 8 bytes is nothing but 2 cube. So, page table size is 2 power 48. After calculating the PTS size, what we need to do? We need to check whether PTS size is less than page size or not. We know page size is 4 KB. That means 2 power 12 bytes. Since 2 power 48 is still greater than 2 power 12, I need to do the one more level of paging. Fine. So, this is for level 1. Now, for level 2. I have a page table of size 2 power 48. I cannot fit the entire page table into one page. That's why I am doing the paging of page table again. That's why 2 power 48 by 12. Now the number of pages is 2 power 36. Now, I know the number of pages in this level is 36. That means number of pages is 2 power 36 and page table entry size is 2 cube. Now, page table size at this level is 2 power 36 into 2 cube, which is 2 power 39. Fine. Now what I need to do? I need to check whether this page table size is less than page size or not. Still page table size is not less than page size. That means 2 power 39 is still greater than 2 power 12. No, so what we need to do now? We need to do one more level paging. Fine. For that, okay, I am going for level 3 paging. Sorry. Fine. I am going for level 3 paging. Here also I will calculate the number of pages first. Okay. So, the page table size is 2 power 39. I divide it with page size. Now I will get the number of entries at this level. So, it will become 2 power 27. Now, number of entries is 2 power 27, but I need page table size. So, to get the page table size, what is the formula you are using? Hash pages in that level, that means this 2 power 27 into page table entry size. That means 2 cube, that is 2 power 30. Fine. Now, we need to compare whether this page table size is less than page size or not. Fine. 2 power 30 is still greater than 2 power 12. That means we need to do one more level of paging. So, I am going for level 4 now. What is the page size? 2 power 30. We need to calculate the number of pages that needed for this page table. Fine. So, 2 power 30 by 2 power 12, that is 2 power 18. This is the number of pages needed at that level. But I need to calculate the page table size. For that, what I need to do? Page table size is equal to number of pages in that level into page table entry size. That means 2 power 18 into 2 cube, that is 2 power 21. Then what is the comparison we are doing? We compare this page table size with this page size. That means 2 power 21 is still greater than 2 power 12. So, even after 4 levels of paging, we are not able to fit it into one page. Now, what we need to do? We need to do level 5 paging. Fine. The page table size is 2 power 21. We divide it with the page size. Now, 2 power 9. This is the number of pages in level 5. Now to calculate the page table size in level 5, what we need to do? Page table size is equal to number of pages in the level into page table entry size. That means 2 power 9 into 2 cube. That is 2 power 12. If you observe this, it is less than or equal to 2 power 12. That means this entire page table can be fit into one page. Got the point, right? Hope this point is clear for you. Now we have reached a stage where page table can be fitted into single page. So after applying paging of 5 levels, we are able to fit the page table into single page. So what they have asked, how many number of levels? They asked for the L value. So in the multi-level paging, how many levels are required? So the answer is 5. Okay. So what are the calculation you have seen? If you have done the test series from ACE or any good institute, you might have observed one thing. Initially, the power in the 2 was 48. Because 2 power 45 are the number of pages and 2 cube was the page table entry size. That's why power in the 2 was 48. After paging at each level, what is happening? Have you observed it? Initially the value is 48. We subtracted 9 from it and we got it 39. We subtracted 9 from it and we got 30. We subtracted 9 from it and we got 21. We subtracted 9 from it and we got 12 here. We stop the procedure here because we know 12 is the number of bits needed for recognizing a word in a page. Fine. So if you observe here, if you observe that 9 change, we just do this. We just subtract the 9 as many times as possible till we get a number which is less than or equal to 12. That means 48 will become, 48 will become 39 and we subtract 9 again, it will become 30, 30. After that we subtract 9 again, we will subtract 21, we subtract 9 again, we will get 12. You observe the point, right? See, so many people might have solved this question, but who has practiced test series questions, they observe this pattern. After doing one level of paging, they understand that after each level of paging, the value getting subtracted is 9, and they just subtract 9 from the power, and they stop the procedure when they will get a value which is less than or equal to 12. This procedure will be faster, and they will get the marks easily, and they'll solve this question very faster. Hope this point is clear for you. What I'm trying to say, whatever the method I have shown you, that is also fine. But if you practice enough questions, you will realize this pattern and you will be able to answer this question easily. This is what I'm trying to say. Fine. This is the third question that is asked from answer for this question is 5. Now the last question. Okay. During the context switching between the threads, which of the following is or are saved? So the answer is program counter is saved, stack pointer is saved, and registers are saved. Registers means general purpose registers. Okay. So understanding this question, actually you know this concept very well. What they are asking, what need to be saved? So the answer is whichever the information that is maintained by each thread, whichever the information that is specific to each thread and that is maintained by each thread, that need to be saved. I'll repeat this point again. Whichever the information that is specific to each thread and that need to be maintained by each thread, that should be saved. If the information is taken care by process level, that we don't need to save. Hope this point is clear. I'm repeating it again. Whatever the information that need to be maintained by each thread, that need to be saved in case of context switch. Let us say if the information that is taken care by process, thread need not bother about it. Fine. So each stack maintains one program counter, one stack pointer, and one general purpose register. But this page table register is maintained by process. So at thread level, thread doesn't need to bother about it. Fine. So answer for this question is A, B, C. That is program counter, stack pointer, and registers. Okay. So however the GATE exam has gone, you have gained so much knowledge. You may not be able to perform well in the exam, but whatever the knowledge you have gained, that may help you in the future. Thank you.